Russia has an energy development strategy extending to 2050. It targets a 30% increase in capacity compared to 2023. How will this be achieved? Through the modernization of infrastructure and equipment, import substitution, and a boost in nuclear power generation. This is a challenge. It's complicated. We are about to tell you how companies are handling it. Here is the first story. Made in Russia. Novoye Deviatkino, Leningrad Oblast. You can feel it right away. It is a powerful and complex thing. The gas turbine. Without it, there would be no light in our homes or factories. Foreign companies used to think they were the trendsetters in manufacturing this equipment. Well, let them tell that to the specialists at the St. Petersburg plant. Manufacturing a gas turbine is a high-tech process requiring specialized materials, as the unit operates under hellish temperatures and at tremendous rotational speeds. While gas turbines for the energy sector were built during the Soviet era, by the early 2000s, production had ceased domestically, forcing the country to rely on foreign units. This meant that the power in homes and factories depended on equipment from abroad. Partially, yes, that was indeed the case. However, in 2018, the Russian government made a strategic decision to restore capabilities and launch serial production, which has been done. The Ministry of Industry and Trade supported the project by Power Machines to develop medium and high-capacity turbines of 65 and 170 megawatts. The project is valued at 25 billion rubles, including 7 billion in government funding. Step 1. Restoring the Design Bureau. It currently employs 150 people. Plus, a system of student design bureaus was established, with universities to recruit young talent. We now have 9 student design bureaus at Russian universities. That creates a flow of around 100 graduates per year. The next steps involved restoring production facilities and establishing new ones. Within 5 years, the full manufacturing cycle was mastered, including critical components like all elements of the combustion chambers. This is part of the turbine's hot section. Previously, these had never been produced in Russia. It involves working at high temperatures and embodies both design and technological solutions, which is unique for the development of this product. It was important to restore the production of cast blades. We invested in creating a new section, a new facility, for producing cast gas turbine blades from nickel alloys. We also restored the coating and machining sections at the Leningrad metal plant, establishing a full production cycle. The result is serial production. Currently, 13 170-megawatt turbines are at various stages of manufacturing. 2 are already being installed at the Kashira power plant. In addition, they are building a different class of turbine, the 65-megawatt version. The first of these will go into operation at the Perm heat and power plant. By 2029, the company aims to produce 10 gas turbines a year. Next, we're going to develop the gas turbine lineup further, boosting both efficiency and power output. A 190-megawatt turbine is currently being designed. Even more advanced ones with a capacity of 300 megawatts are in development, and this is just part of a huge list of equipment. Without this production, neither thermal, hydro, nor nuclear power plants could operate in Russia or abroad. In particular, for nuclear power plants, it is the only company in the world that manufactures 2 types of turbines simultaneously, those based on low-speed and high-speed technology. The lead unit of our low-speed turbine is currently installed at the Kursk nuclear power plant, and we expect it to launch by the end of the year. Meanwhile, high-speed turbines with a capacity of up to 200 megawatts are installed both in Russia and around the world. They already have a fairly extensive track record. And this isn't the end. We continue to expand the lineup. Currently, we have 5 turbines in the works, including ones for fast neutron reactors. This, once again, is a new development by Rosatom. Russia's energy sector plans to commission about 88 gigawatts of new capacity by 2042. This will require roughly 270 gas turbines and 340 steam turbines. To supply the industry with this equipment, Power Machines will invest around 75 billion rubles in production over the next 5 years. Furthermore, given the company's rich export experience, Russian technologies hold significant potential in international markets. And I think that our track record with gas turbines in the Russian Federation will allow us to further expand the export of this equipment. After all, exporting complex, high-value-added products brings more than just profit to the manufacturers. It contributes to the budget. This was discussed at a working meeting between Federation Council Speaker Valentina Matviyenko and the CEO of the Russian Export Center, Veronika Nikishina. The fact that revenues from the non-resource sector of the economy are growing in both the federal and regional budgets is, in part, to your credit, the credit of the Russian Export Center. Thank you very much. Indeed, while revenues from non-resource exports account for 7% of the federal budget, they make up 8% of the consolidated regional budgets. This is the result of the consolidated efforts of both the federal and regional governments. I would like to note that 85 regions, including the DPR and LPR, now possess their own export support infrastructure, and we operate as a single, mutually complementary organism. And the more diverse our export product line becomes, the more we strengthen this integration. Products that are very much needed by the Russian market, but at the same time have a rich export potential, are being produced more and more. St. Petersburg has a lot to tell here, in addition to gas turbines. The symbol of our successful import substitution, tunneling shields for the construction of the St. Petersburg subway. This is very important for us. After the collapse of the Soviet Union, they were not produced in Russia. Today, a quarter of Russia's original pharmaceutical products are made. That's right, in St. Petersburg. At this year's St. Petersburg International Economic Forum, for the first time ever, the value of contracts concluded by St. Petersburg for industrial development has surpassed that of transport construction, totaling over 500 billion rubles. Next, we head to the Sverdlovsk region, where there is also an example of how it is possible to create and successfully produce very useful products for the energy sector. Made in Russia. Urals, Sverdlovsk region. Such seamless stainless steel pipes, which are very popular at various advanced manufacturing facilities, were often purchased abroad in the past. Well, that's not exactly impressive for a country striving for technological sovereignty. The situation will be corrected, decided at this plant in the Sverdlovsk region. We'll show you how that turned out right now. Nuclear power, chemical industry, machine building, instrument engineering. In all these high-tech sectors, heat exchangers are used to heat water, and they require seamless pipes. Manufacturing them is difficult. To obtain such a pipe, it undergoes repeated mechanical stress via cold rolling. Then comes the restoration of the metal structure through recrystallization, followed by lubricant removal. Consequently, mechanical processing is repeated. This pipe is actually manufactured from a larger pipe produced by hot piercing. When the new production facility opened in 2020, following the modernization of workshops built over half a century ago, more than 100 jobs were created. Staff were trained under the Future of White Metallurgy program, which has proven its worth since 2011. Our students are trained according to the principle, 60% practice, 40% theory. The main feature is that, depending on their specialty, the students acquire multiple competencies. They join the Federal Professionalitet project. By the way, there are already 12 clusters working in the Sverdlovsk region. We'll launch another one this year, and we have 7 more in the construction phase, which will also launch within 6 months, or maybe 9. And so, through the joint work of industry specialists, teachers, and the youth, we put together a program That is interesting to young people. It allows them to move seamlessly from their studies right into the factory. But it is not only about developing educational programs. The state, together with the employer, allocated us 100 million. And we bought, for example, well, our proudest asset is the non-destructive testing laboratory, as well as a huge number of rolling mills. They train specialists for both the company and the entire Sverdlovsk region. The guys sign a target contract. This is, again, a condition of our employer. In addition to the fact that the students are provided with a workplace upon graduation, the guys also get certain perks as part of their training. It's an increased scholarship. Now it's 5,000 rubles per month per student. Existing employees are also being retrained. Betting on modern equipment and automation allows them to steadily increase production volumes. Is this all private investment, or did the state help? This is co-financing. Under federal programs, yes, funds were allocated for the purchase, for the renewal of the fleet of equipment. And by the way, among the 150 units of modern equipment, some are Russian. We use Russian-made rolling mills. They were developed by the Institute for Non-Ferrous Metal Processing. There are other pieces of equipment made in Russia. There are thermal units produced by the TKM company from Stary Oskol. These units are also unique, the only ones in Russia, modern, high-tech, and reliable. Pipes designed for extreme environments undergo mandatory testing. The metal structure is evaluated under a microscope, and we conduct mechanical tests so as not to let down clients across Russia and abroad. Specifically, we supply these pipes for nuclear power plants, for various plants, including the Turkish nuclear power plant. Our pipes are used in heat exchangers there. So, the geography of our deliveries is broad. It includes virtually all of Russia, the CIS countries, and those countries where nuclear power plants are being built by Rosatom. What are the other benefits of export development? Since in our case we are talking about high technologies, it is important to maintain our reputation. This is a major factor in boosting our product's competitiveness. To maintain a presence in highly competitive export markets, we must constantly improve quality, reduce production costs, and increase labor productivity. As a result, it is not only foreign buyers who benefit from this effort, but also domestic buyers and the Russian economy as a whole. Of course, support for exporters is crucial here. We'll talk about that in a moment. But now, let's head to the Perm region, where they are training staff for the energy sector and developing new technologies for the industry. Made in Russia. Perm Krai. How often do we hear that time is always in short supply? Some say health, some say money. What's more, natural resources are clearly running out faster than we would like. That is why the Perm World-Class Research Center is called Rational Subsoil Use. We'll find out right now what results have already been achieved. This is not training for the sake of training. When the center was created in 2019, its goals were to train specialists, develop innovative technologies, including import substitutes, and implement them into production. Business is the target client. Does it work? Of course, successfully since 2019. And according to the results of last year alone, we became the first center in the country. So we're officially ranked #1 in terms of our performance. Initially, the anchor partners were oil-producing companies. They are still working together to this day. Here is an example of one of the solutions. The destruction of the pipeline can be slowed down several times, and the overall volume of oil production, I think, can also be increased by 2 or 3 times, if not more. Vyacheslav works on the development of reagents for petrochemistry. Initially, he synthesizes a small quantity of a substance designed to enhance oil recovery. An analysis is performed. Next, a reactor comes into play, capable of large-scale production. The batch is sent for industrial testing. If successful, the Perm manufactured product will replace imports. So our final goal is a full production cycle entirely within our country. That is, well, to exclude foreign supplies altogether. To make it just as good or even better. Of course, no worse, yes. As for this solution for oil refining and energy sector enterprises, it is already being used by over 4,000 people every day. The manager looks at the map. Aha, right here, and sees the movement of their employee. The field inspector's mobile app works like this. The manager assigns tasks to subordinates via a computer. The inspector receives the assignment directly on their smartphone with instructions on where to go and exactly what needs to be done. He performs these operations, logs them, can send a photo or a result, and record readings from a specific sensor. And all of this is automatically compiled into a daily personnel report. This solution was well received by more than just the energy sector. Now they are improving workforce management efficiency on the railways. Meanwhile, programmers are taking the next step. They are working to enable the field inspector's tablet to autonomously collect data from industrial control systems and various sensors. The information would be pulled directly through the smartphone without using any third-party networks and land right with the client, on the engineer's desk, so to speak. It's safer that way. Yeah, of course, the center has already expanded beyond, developing solutions solely for the energy sector. Tell me, please, what is bothering you? The tooth hurts. The tooth that is bothering you has a cavity. We will treat tooth number 6 on the right. The Android patient is an interesting collaboration between science and business. There is a company in Perm called Promobot that manufactures robots. Over 600 variations of emotional expressions, moving the eyes, jaw, and main facial features. This is the highest count of artificial muscles in a robot's face. We humans have about 40 in our face. Our robot has 28. The closest market equivalent has no more than 15. Created jointly with 3 medical universities, this robot is designed to assist students. When they need practice but don't have their degree yet, it is ready to serve as a patient. Moreover, the artificial intelligence can simulate quite complex clinical situations. It can even faint, right? Yes. The team working on it, the dental assistant and the dentist, must take the correct actions to bring the robot out of that state. More severe conditions have also been developed, such as anaphylactic shock, and the dentist's actions are monitored by a smart tooth with brains. You have the ability to monitor temperature, pressure, and vibration on the tooth, right? With the help of neural networks, you can determine the dimensional and geometric characteristics of the treatments you are performing. That is, the size, depth, and milling parameters of everything required. Another innovation is undergoing preclinical trials. A bionic ear prosthesis will make it possible to restore hearing. And there is an industrial partner ready to manufacture this medical device once the appropriate state registration procedure is complete. One of the center's new focus areas is unmanned aviation. We are on the verge of creating a new industry in the country, which is why a network is currently being established, a research and production center for unmanned aerial systems. We have created one such center in Perm, in the Perm territory, and have directly become its management company. Work is already underway on new drones that can be useful for both geological exploration and pipeline inspection. The models are built from composites, including recycled materials, and engines are being developed. But our primary task is to create an infrastructure here for our companies in the region to produce their products, including using this model range. That is to say, to scale it up and produce it. Produce their own drones here. Yes, a shared use center has already been established, offering companies both ready-to-use facilities and modern equipment. All of this is being done with a federal subsidy, specifically under the program to create research and production centers. As for workforce training and scientific work, new opportunities will be unlocked by the future of Parma Inter-University Campus, which is being built under a national project. Plus, it is important to improve conditions and modernize curricula in existing educational institutions. We must ensure that academic departments operate not only directly within university buildings, but are also attached to enterprises. And this is happening. I can cite examples here in the chemical industries and again in mechanical engineering. And the task is to participate as much as possible in projects like professionalitet. We highly appreciate the effectiveness of this project, and it is no coincidence that we are ranked 11th in the country. For the number of these clusters opened, there are 10 open now. 44 institutions are involved, along with 50 industrial partners. But we're going to, I think, double the number of these clusters. The hero of our next story from the northern capital, which is making a huge contribution to the development of nuclear power, is also actively training specialists. Made in Russia. Kolpino, St. Petersburg. Just look at the sheer scale of it. This plant in St. Petersburg is equipped with machine tools, capable of high-precision machining of workpieces weighing 400 tons and measuring 10 meters in diameter. Unique equipment for unique components. Right here, for example, is a circulation pump. Overall, they make things here that are absolutely vital for nuclear power plants in Russia and abroad. You're about to see it all. Rosatom State Corporation has a machine-building division. It includes enterprises that design, manufacture, and supply equipment. They are in different regions, including St. Petersburg. We are located on the site of the largest enterprises of the machine-building division, including Urals and Spyetstal. Perhaps the most important benefit is that the entire manufacturing process takes place on this one site. From the metallurgical stage, where the workpieces are created in the special steels department, to the final output of equipment. For nuclear energy, everything happens here. It is a full production cycle. It begins with castings made from special alloys, of which there are more than 300. For example, metallurgists here can manufacture unique ingots, weighing 443 tons. After machining comes assembly and welding and, of course, testing at every stage. Digitalization aids the process. Beyond the equipment condition monitoring systems, we can also boast about our remote logistics. We even have remote quality acceptance inspections. AEM Technologies facilities can produce up to 5 equipment sets per year for the reactor and turbine halls of nuclear power plants, including modern VVER 1200 reactors, which are safer and more powerful. They also make pumps, steam generators, pressurizers, and all sorts of vessels. But in general, the products themselves can be called unique. Essentially, nobody else makes them. In Russia, yes, indeed, we are the leaders in manufacturing equipment for the nuclear power industry. As of today, Rosatom has a total of 39 power units under construction, including projects for 7 foreign plants. So the volume is very large, and we continue to ramp up our pace. They deliver abroad in style. Here is a reactor wrapped in a G-gel patterned cover departing for Egypt. It is the same story for many countries where Russia is building nuclear plants: China, Turkey, India. And cooperation is set to expand. For example, during Vladimir Putin's state visit to India, 29 joint documents were signed following talks with Prime Minister Modi. Trade turnover has seen record growth over the last 3 years. It is already at $64 billion and could well reach 100. In the first 9 months of 2025 alone, the volume of export deals, supported by the REC, reached 43.5 billion rubles. This shows that despite all the difficulties, despite all attempts to isolate us, not only is it failing, but more and more companies are starting to see export as an opportunity to scale up their production. It is an opportunity for any company that has the desire and the product to become an exporter, and we will help. The support includes certification, participation in exhibitions, assistance with entering marketplaces, and compensation for logistics costs. The measures are constantly being improved, just like the exports themselves. Development will focus on macro regions, from which supplies can then be distributed to neighboring countries. Logistics support tools will be tailored to this, alongside the traditional subsidy for export cost reimbursement. We will focus on the most export-oriented high-tech products,
продукцию высокотехнологичную,
that require this subsidy to remain competitive. For instance, it is not just nuclear power products from this enterprise that are in demand on foreign markets, and of course within Russia. Equipment for the petrochemical and gas processing industries is made here as well. We are fully secured with orders. We have a roadmap in place until 2045. Accordingly, it includes both nuclear energy and new types of equipment, an area where we are also testing our capabilities and picking up the pace. New products are also in the plans. We want to manufacture equipment, specifically next-generation reactors. Naturally, the world is evolving. It doesn't stand still, so we need to improve and gain momentum. And so, we are trying to keep up with the times. But doing this without specialists is impossible. Here is how they are solving the staffing issue. We cultivate our staff starting right from the university level. Our HR department works very closely with mechanical engineering universities and the Polytechnic University. There are many institutes that they visit to select students and make offers. Consequently, students can already complete internships at our facilities. Over the next 7 years, the country's workforce requirement stands at 12.2 million workers. These figures come from a Ministry of Labor forecast, compiled taking into account the new Personnel National Project. It is crucial to develop cooperation between business and educational institutions, alongside targeted training, mentorship, and equipment upgrades. If we have the specialists, we will have technological sovereignty, including in the energy sector.